Uh, Welcome to this video. As we have been doing, I'm going to explain example 8 and example 9 of topic number 5, straight line graphs of pure mathematics 1 under Pearson and Excel International advanced level. And let's go straight to page 91, and we meet example 8, that the line y is equals to 3x minus 9 meets x-axis at point A. Find the equation of the line with gradient 2/3 that passes through point A. First of all, it is important to note that the line with this equation meets the x-axis. And as we have explained in previous videos, the x-axis is this. This is the x-axis. And the other mathematical name of the x-axis is y is equals to 0. So any value, any point along the x-axis, y is always equals to 0. So it is important to first of all get the coordinates of point A by equating the whole of this right-hand side to be equals to y, which is obviously going to be 0. So we have 3x minus 9 is going to be equals to 0. And at that point, we need to realize that x is going to be equals to 3. Having said that, the point A, of course, have coordinates 3, 0. That is point A for you. And then we are told that find the equation of the line with gradient 2/3. We are going to talk about that gradient. Gradient 2/3 that passes through point A. How do we get that? Now, we have point A here, which is 3, 0. We have the M, which is 2/3. And we know very well the equation of a straight line that when we have the gradient and one point is given by y minus y1 is equals to mx minus x1. It happens that this is x1 and this is y1. So if we substitute here, we're going to get something that looks like y minus 0, because y1 is 0, is equals to 2/3, which is the gradient, multiplied by x minus x1, which happens to be 3. And at that point, we are going to have y is equals to 2x over 3 minus 2 over 3 times minus 3 is minus 2. And now we need to probably give this equation in the form of ax plus by plus c is equals to 0 as per the instructions in the question. And before we get that, you can see the coefficient of x is a fraction. So we need to multiply each and every term by positive 3 so that we have 3y is equals to 2x minus 6. Rearranging all these terms, we are to have it in this format. Then we are going to have 2x minus 3y minus 6 is going to be equals to 0. If you may not like bringing 3y across, then you may also have minus 2x plus 3y plus 6 is equals to 0. Both of those equations are correct. Either way, you have reached there. But it is example 9 that I want to explain in the same kind of way. In this example, I want to explain something to do with example 9 and say something about it, because we are told that the line y is equals to 4x minus 7 and another line 2x plus 3y minus 21 is equals to 0 intersect at point A. Both of these lines intersect at point A. And then we are told that the point B has coordinates. There is point A whose coordinates we will know. Then there is point B who has coordinates minus 2, 8. Minus 2, 8. Find the equation of the line that passes through points A and B. And write your answer in the form of AX plus BY plus C. All that is expressed in example 9 and on page 91. First of all, we are given this line and this line, and we are told that they intersect. It is important to note that at the point of intersection, at the point of intersection, at the point of intersection, both lines are equal. We have seen this in a different video. At the point of intersection, both lines are equal. What does this mean? At the point of intersections, they both have the same value of x and the same value of y. So, meaning that we can easily solve the two equations simultaneously. And now that this one is already in terms of y, then we can substitute this equation in the second one and have 2x plus 3. Now y becomes 4x minus 7 minus 21 is equals to 0. We have substituted y in equation 2. And expanding this, we have 2x plus 12x minus 21 minus 21 is equals to 0. Of course, what does this mean? 2x plus 12x is 14x minus 42 is equals to 0. So easily, 14x is equals to positive 42. And dividing everything by 14, you realize that x is equals to 3. And if x is equals to 3, we don't know the value of y at the point of intersection. But of course, yes, we can have our 3 there, awaiting to fill the value of y as coordinates of point A. But if x is 3, we can substitute this 3 in the easier origin of the original equations, which we say when x is equals to 3, then y is equals to 4 times the value of x3 minus 7, which is y is equals to 12 minus 7, which is 5. And you can already see now the point A has coordinates 3, 5. So we can have a 5 there. That is point A for you. Now, we need to now bring both point A here, 3, 5, and point B, whose coordinates are minus 2, 8. So what is the equation of the line that is passing through these 2 points and in the form of ax plus by plus c is equals to 0? You realize that we don't have the gradient here. So the first thing to look for is actually the gradient. And the m, as you know, is y2, which is 8 minus 5 all over minus 2 minus 3. And this is the 3 over negative 5, which is basically minus 5, negative 5 over 3 as the gradient. Now, the equation of a straight line joining the 2 points, now we bring a general point y. Let's bring a general point y minus y1. We may choose y1 to be this particular point, minus 5 is equals to the gradient, which is minus 3 over 5, which is m, x, general value of x, minus x1, which is a 3. Now, expanding this, then we are simply going to have something to do with 5y minus 25. We've just multiplied both sides by this 5 is equals to minus 3x plus 9. And at the end of the day, we are going to have our equation to be equals to 3x, bring it across, plus 5y, of course, minus 25 minus 9 is going to be minus 34. Now everything equals to 0. And that is our equation of the line that is joining both point A and point B. Please note, we first began by getting the coordinates of point X, whereby the coordinates of point A, the point of intersection of the two straight lines. And of course, we did that by solving the two simultaneous equations. After we got that, then we got the gradient of the line that is passing through point A and B. And of course, we used the formula to get the equation of the line AB. There you are. Please again visit my channel, subscribe, share, and like. It's going to help us a big deal.